Hey guys, okay, so I'm trying to get set up here. I'm going to do the lesson. All right, so I'm going to go ahead and finish this lesson for you guys. So we are on, what page is that, 226? I hope you can see this. I'm trying to screencastify here for the first time. So, all right, focus questions. So we're talking about rotations. I'm going to finish the lesson for you guys. What effect does a turn have on a figure? So if you have a figure, which I don't have a figure, anyway, okay, here's your figure. Okay, my daughter's book, Clifford. Okay, so if you have a figure here and you rotate it, right? Remember we talked about a rotation. What what effect does it have on it? So when a figure, my bad, is turned, right? We want to use our simple word. I don't know what effect happens to it. I don't know. It's your paper. Go ahead and fill it out, right? Everything stays the same, right? So it's a rigid motion, just like a translation and a reflection, right? It's a rigid motion. You're not changing the shape or size. So when you have a figure and you're turning it, what happens to it? Well, it's just facing a different direction depending on which direction you're turning it, right? So again, we're talking about rotations. So think about your definition of a rotation. In order for you to have a rotation, you got to be spinning, turning around a center point of rotation, and you have to tell me how far you turned, right? And then once you turn it, you got to be able to tell me where the new position of your points are. Okay, so here we go. Moving on. Number 1, use arrow notation to show how triangle JKL maps to its image after a rotation of 180. So, whoa, it's kind of a lot. Use arrow notation. So you're going to say the caterpillar went to this or turned into this after you rotated, right? So use arrow notation to show how triangle JKL maps to its image after a rotation of 180. So, okay, we're talking about rotations. This is going to be really annoying, so bear with me with the clicking here. So if we're rotating 180, how many rotations is 180? Well, one rotation is 90. 2 rotations is 180. So you're going to rotate 2 times. Now you're thinking, if I rotate 2 times, 2 quadrants, that's even. Remember that 180, it doesn't matter if you go clockwise or counterclockwise. So it doesn't matter if you go with the clock or against the clock. So 180 is 2 times. So you're going to move your point. So let's look at J first. Remember what I told you? It's all about the point. The point. Okay, so do 1 point at a time. Don't try to do the whole thing at the same time. Try to rotate 1 point at a time and see where it ends. So here's J. I'm going to rotate J 2 times. So 1, 2. So what quadrant is J in right now? It was in 4, but now it's in quadrant 1, quadrant 2. So a rotation, let's go ahead and undo that there. So it's going to be in not quadrant 1, but quadrant 2. And remember, even Steven, right? Even rotation, you keep the XY the same. Okay, so I don't know. I hope you could see over here. What's the rule? If you have, okay, I can't write there. I'll write here. The rule was when P, right, you got point at this place, X, Y. Wow, okay, sorry guys. So you got this point at X, Y, and it's going to map to this other point, right, the image, once you rotate, right? We're talking about rotation. So remember we used green for rotation. So what's my instruction here? So I'm going to rotate 180. So if I rotate, that's how I'm going to change my point, right? It's all about the point. So I'm going to move that point 2 times because it's 180. So if I move the point 2 times, I'm in quadrant 4. I'm going to go to quadrant 1, quadrant 2. The rule says that if it's an even rotation, you keep your X and you keep your Y, and then all you do is change the signs. depending on the quadrant. So if I was in quadrant 4, but now I'm in quadrant 2, right? I'm in quadrant 2. So what are my signs? Negative, positive. So now go to your rule. All your x's are negative and your y stays positive. So let's go here. Guys, where's J at? J is at 1, negative 1. So now you're going to go to J prime. The rule says keep your x and y the same. There it is. X, y, x, y. But now you're in quadrant 2, so then your sign is now negative, comma, positive. Your x's are negative, your y's are positive. Okay, now let's do K. You're in quadrant 1. Do 180 rotation. That's 2 moves, 2 quadrants. 1, 2. What quadrant are you in? Quadrant 3, right? 1, 2, 3. So you're in quadrant 3. What are your signs in quadrant 3? Negative, negative. So let's go ahead and find the original point. Where's that at? 4, comma, 1. So 4, comma, 1. So then over here, remember the rule, even rotations, keep the xy. So 4, comma, 1. But now we got to change the sign, right? Because we're in quadrant 3. After K moved 1, 2 quadrants, you're in quadrant 3. So your signs are now negative. We good? Go ahead and do this one yourself, guys. Okay, where's L at? How many rotations? So 1, 2. What quadrant are you at? So those are your signs. Okay, so I'll give you some time. I'll go ahead and pause this so that you guys can have some time. Okay, so here we go, guys. That should have been your answer. 3, comma, negative 3. So that's where your pre-image is at 3, comma, negative 3. Rotate 2 times, 1, 2, or you could even go 1, 2. You're still in the same quadrant too. Remember, 180 doesn't matter which way you go. And so if you're in quadrant 2, your signs are negative, positive. Boom, you're done. Okay, guys, look at this one. This is one of the ones that it looks difficult, right? I mean, look at it. It's like, oh, so much is going on. They're just points. So the vertices of this parallelogram, that means you have 4 points because you got 4 sides, are W, X, Y, and Z. The vertices of its image, so here are the vertices, W prime, X prime, Y prime, Z prime. What is the angle of rotation? AKA, in other words, right? Also known as, how many times did you rotate? So look at the numbers. Look at the quadrants. So this is actually a simple question. They just want to try to see if they can trick you to, I don't know, maybe paralyze you. Look at, guys, what quadrant are you in if you're negative, positive? Isn't that quadrant 2? Right? Negative, positive, yeah. And then look at over here. Look at your image. Where did you go? Negative 1, 1. Again, aren't you in quadrant 2? So hold up. You started in quadrant 2 and then you ended at quadrant 2? Let's go to the next point. 3, 2. What quadrant are you? Positive, positive. Positive, positive. Isn't that quadrant 1? Okay. Quadrant 1. So look at X prime. Look at your image. 3, 2 again. So again, you're in quadrant 1. So you started at quadrant 1, rotated, and now you're in quadrant 1 again. How many degrees is that? How many rotations do you have to do in order to end up where you started? So you started in quadrant 1, 2, 3, 4, boom, back in 1. How many rotations was that? 1, 2, 3. No, wait, sorry. 1, 2, 3, and then 4. You're back. So your answer is 360, guys. Even though it looks like a crazy problem, it's not. You have to take the time to think about all about the points. Where's my pre-image point at? Where did it go? And then where did I end up at? Okay, I'm running out of time. I think you guys can finish the rest. All right.